All right. Valency and ionic charges is not the same thing. Valency and ionic charges is not the same thing. What does that mean? When we use the word valency in chemistry and we use the word ionic charges in chemistry, what does that mean? Now you need to draw the periodic table for you to understand this concept. Now we have the periodic table. Look like this. Looks like this. Then we have this. Okay, this is just a sketch of the periodic table anyhow. So I have this. Let's make it more visible. And I have this. So this is group 1, group 2. This is group 3. And this is group 4. And this is group 5. And this is group 6. This is group 7. This is group 8. Or group 0. Now, we're going to fill in the atoms of, we're going to fill the elements in this periodic table. And then we have the transition method, which are 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now over here we have the F block elements. So this is called the F block. This is called the S block. This is called the D block, or the transition element, and this is called the P block. All right. Now, how do we find valency? How do we find ionic charges? All right. Before we continue, I want to tell you that valency is simply the combining power of an atom of element. I take that again. Valency is the combining power of atom of element. You can put a full stop there, or you can continue by saying valency is the combining power of atom of element, showing the number of electrons gained, lost, or shared during chemical combination, which shows the number, or which indicates the number of electrons shared, number of electrons gained, or number of electrons lost during chemical bonding. But ionic charge is simply talking about the charges on an ionized atom of element, which could be a positive charge known as cations, which could be a negative charge known as anions. So we're looking at the elements. Of course, hydrogen is here, followed by helium. Now, for an element to be in the group 8 or the group 0, known as the noble gases, because the elements in group 8 or group 0, they are in a stable state. They are in a stable state, and they cannot, or they hardly undergo chemical reactions. You get that now? Because they are already stable. Why are they stable? They are duet, or they are octet. The electronic configuration is duet. Duet means 2, or the electronic configuration, that is the structural configuration, is 8 or 2. Let's move to that place before we get what I need there. So we have there hydrogen, helium, we have lithium, we have beryllium, we have boron, we have carbon, we have, as a little bright green cannot, we have nitrogen, we have oxygen, we have fluorine, we have neon. Now let's take this hydrogen, helium and neon. Helium has the configuration of 1, 2. So you see, this is duet. So it has a stable electronic configuration. And then we have this guy here, which is neon. Neon has, first of all, it's in number 10. So we have the first 1, 2, and then we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 2:8. Notice that this 8 is duet, it's octet. And then this 2 over here, this one is 2 over here, it is duet. That's why they have a stable electronic configuration, and then they hardly undergo chemical reaction. Meanwhile, the valency electrons of this guy is 0. There's no valence electron there. You see, because the outermost shell is completely filled And then the charge also is 0. There is no charge there. You know why? Because the outermost shell is completely filled. Now let's continue. So we have the neon, we have the sodium, we have magnesium, then aluminium, then we have silicon, then we have phosphorus, then we have sulfur, then we have chlorine, then we have argon, okay, and then we have potassium, and then we have calcium. Now, in the 21 to 30 element, from 21 to 30, you can use the acronym say to Vero, cry more for company Nigeria, copper, and zinc. But for 1 to 20, you can use the acronym, let's go over there. It says, he has little bright brain, cannot offer full 9 subject. Let me take that a little bit slower. He has little bright brain, cannot offer full 9 subjects. Many art students prefer such combination as physics, chemistry. Now 21 to 30, say to Vero, cry more for company Nigeria, copper, and zinc. So say should be scandium, 2 should be titanium, Vero should be vanadium, cry should be chromium, cry more should be manganese, cry more, manganese is more, cry more for company is cobalt, company Nigeria, say to Vero, cry more. After the more, 4, say to Vero, cry more, 4 is iron, company, that is cobalt, then copper and zinc. So sorry for that. Say to Vero, cry more for company Nigeria, copper and zinc. So you have 21 to 30 now. Say to Vero, cry more for company Nigeria, copper, zinc. All right. So having said that, let's deal with these guys over here. And then to deal with those, I'll need my cleaner. Now, these guys are known as the D block. The D block is called the transition metals, and they have a variable oxidation state. The oxidation state is not just one ion or one anion or one cation. They have variable oxidation state. And let's look at this. Let's look at iron, for instance. Ion can be ion 2, and then you can have ion 3. Ion 2 is known as ferrous, and ion 3 is known as ferric. So you see that it has a variable oxidation state. It's not a stable oxidation state, it's just variable, just moving from one form to another. Then we take someone like copper. Let's look at copper. Copper over here. Let me use a blue pen now. Copper has a plus charge and copper has a plus 2. Now this is called cuprous, and this is called cupric. All right, so you can see a variable oxidation state. Now this is the ionic charges plus 2 for cupric, the ionic charges plus 1 for cuprous. Now, but the valency here is 1, not plus 1. The valency here is 2, not plus 2. The ionic charge is plus 2, not just 2. The ionic charge is plus 1, not just 1. So you can know what you are doing. Now we have this guy in group 1. Any element in group 1 should have a plus 1 charge. That is the ionic charge. So we have hydrogen is plus 1. So we have sodium is plus 1. So we have potassium is plus 1. So next time your chemistry teacher writes sodium to be plus 1, write hydrogen to be plus 1, write potassium to be plus 1, is because all the elements here carries a plus 1 charge. Now, what are the elements in group 2? Elements in group 2, like the magnesium carries the plus 2, and then calcium carries the plus 2. You know why now? All the elements in group 2 carries the charge number of plus 2. That is the ionic charge. But the valency, which is the combining power of those atoms of element, number of electrons shared or lost or or gain during chemical combination is 1 year, is 1 year, is 1 year, is 2 year, is 2 year. That's valency. But the ionic charge, remember to put the charge, whether positive or negative. Now we move to the next one. The next one is the group 3. Group 3, like the boron there and the aluminium, they should have a +3 charge. Aluminium has a +3 charge. Now, you see that whenever you see an aluminium having a +3 charge, it means it has been ionized. All right? When you see a boron having it means it has been ionized. Meanwhile, this ionization of these charges is known as ionic charge, but the valency is called 3. All right, we move to the next one over there. So we have carbon and silicon. In group 4, if you look at the periodic table, if you study the periodic table, you notice that group 4 has a variable oxidation. Sometimes they're +2, sometimes they're +4. But they are the group 4 is +4 charge, like carbon is +4, but sometimes they're +2, sometimes they're +4. For instance, you see silicon appearing in +2, and that is because of the periodicity of that periodic group. All right, so we look at this guy over there, group 5. Any element in group 5, any element starting from here, to get the group 5 is 5 minus 8, which is -3. So that nitrogen is -3 and phosphorus is -3. You notice the -3, which is for nitrogen, for phosphorus. These are the ionic charge, and the valency is just 3. All right, we go to the one of oxygen. Oxygen is in group 6. So we have 6. Let me change my pen now. So we have 6 minus 8. And 6 minus 8, that is -2. So that sulfur is -2 and oxygen is -2. That is why this element, you can know how to find the ionic charges and the valency of an element now. So let's move to the group 7. In the group 7, we have 7 minus 8, that is -1. Just, you don't write -1 like this in chemistry, just the -1. We know you're already talking about -1. So we have chlorine to be -1, we have fluorine to be -1 as the charges, and the valency is just 1. Then the one of group 8, please, 8 minus 8 is equals to 0. They have no charge, they have no valency. So we thank you very much for watching. This is all we got for you. If you have a question on this or any other thing, drop it on the comment section. We will attend to you. Remember, I want to remind all of you that science is easy. Thank you very much for watching. Have a great day.